Next, we will introduce a two-sided finite limit. As a part of introduction, we will discuss the definition, interpretation, and a few examples. We associate the following behavior around the point a, L with the following limit statement, called the two-sided finite limit. Note that we do not suggest that the graph must approach the point in any particular way from both sides. It can approach from above on the left and below on the right, and vice versa, or any other combination, and in any way in between. The point itself may or may not be a part of the graph. All of these behaviors are described with the same limit statement and schematically can be expressed with two arrows starting on the outside of the point and ending at the point. We say f approaches to L as x approaches to A from both sides. Frequently, we omit the plus-minus notation and simply say f approaches to L as x approaches to A. Now, if for whatever reason the left and the right-sided limits do not match, or function doesn't exist on either side, then we say that the two-sided limit doesn't exist, and simply write DNE. So, to interpret the two-sided finite limit, we would first read it as f approaches to L as x approaches to A from both sides, and then locate the point a, L on the coordinate plane and draw the following behavior. Note that from the statement alone we don't know how exactly the graph approaches L on each side, and whether the point itself is a part of the graph or not. The two-sided finite limit statement only tells us that both left and right-sided limits are equal to one another. For instance, that is what one would imagine when seeing the following limit statement. It shows that f approaches to 1 as x approaches to 2 from both sides, and that's all we can learn from the limit statement alone. Let's do an example. Consider a function defined by the following graph, and let's find the following limits. In other words, let's write the two-sided limit statements to describe the behavior of the graph at the following locations when possible. To find the limit, we need to determine the value which the function approaches to as x approaches to -2 from the left and the right. It is easy to see that the function approaches 1 from the left and 4 from the right. Therefore, the limit doesn't exist. To find the next limit, we need to determine the value which the function approaches to as x approaches to 0 from the left and the right. It is easy to see that the function approaches to 0 from both sides. In other words, f approaches to 0 as x approaches to 0 from both sides. Therefore, the answer is 0. So we found the limit. To find the next two-sided limit, we need to determine the value which the function approaches to as x approaches to 2 from the left and the right. It is easy to see that the function approaches 4 from both sides. In other words, f approaches to 4 as x approaches to 2 from both sides. Therefore, the answer is 4. So we found the limit. Finally, to find the last limit, we need to determine the value which the function approaches to as x approaches to 4 from the left and the right. It is easy to see that while the left-sided limit is 2, the right-sided limit doesn't exist. Therefore, the two-sided limit doesn't exist as well. We discussed the definition of a two-sided finite limit using the graphing approach.